Alright, welcome back. We're going to be looking at the back of the 4.5 worksheet, Form B. We're going to start off with number 7, which says y equals -1 times the tangent of x. So we do have some more interesting things going on now. We have a value for a that's just not +1. So with tangent, just like with cotangent that we looked at the front, we can always start off with our range, which will be all real numbers. We're skipping domain and asymptotes until we're done graphing. Amplitude, even though our a is -1, technically for amplitude and with period, we should be using the absolute value of that letter. So we should be just writing +1 here for our amplitude. For period, for tangent, just like we said for cotangent, it's going to be pi divided by the absolute value of b, which here we don't see anything, so that means it's 1. So here our period is pi. Phase shift, we don't see anything, so we can write NA or 0. Likewise, for vertical shift, we don't see anything, so NA. So since we don't have any shifts, we can go ahead and draw our normal x and y axis. And just as I've been saying, we can split the y-axis into halves, and that'll be -1 and +1, since we put our amplitudes there. And then our x-axis, we get tick marks halfway through, and that would be our period, so pi and -pi. For every trig function, we want to split our periods up into quarters, because that's where we have our dots or asymptotes. Here we have tangent, which if we look at our notes, we notice that tangent, the S-curve is actually centered on the y-axis. So that means we have half a period to the left and half a period to the right. So our period is pi, and I just said we have a half of the period to the left. So that means our period, our cycle, would actually start at -pi over 2. So we can draw that vertical asymptote, and then we'll go a period to the right of that to draw our end of our cycle, which that would be at +pi over 2. We don't have to add in these labels. We could just keep it with those -pi and pi. We don't need to add in these extra labels on the x-axis. I'm doing that just to help us understand what's going on. So before we start drawing our S-curve, we need to remember that we did have that negative sign out in front of tan. On my other graph, I said tangent looks like a plus sign, so it would look like this, and then cotangent doesn't look like a plus sign, so it would look like a negative curve. Except we have a negative out in front, and we remember that this negative means we would flip it across the x-axis. So now our tangent curve is actually going to look like a cotangent curve because we have this transformation. So it doesn't affect us for the first dot we make, but it will affect us overall. So if we look at this, our first dot is always that middle dot that is on the x-axis unless we have a vertical shift. So here we have our first dot halfway in between our two vertical asymptotes. And then our next one, we would usually go to the right a quarter of the period and then up. But since we have that negative sign, we would go right a quarter of the period and then down an amplitude. And then to the left a quarter of the period and then up an amplitude. And then we just draw that S-curve. So it goes through the 3 dots, but looks like it's approaching our vertical asymptotes. We would usually draw our next cycle to the left, but I have all that junk over on the left, so let's draw it on the right. So I would start at my vertical asymptote, and I would need to go a period over to the right. So here that means 1, 2, 3, 4 tick marks. So here would be my next period, and that would be at 3 pi over 2, if we wanted to label it, but we don't have to. That would be where the next one is, and I can start doing my dots again. The middle dot, halfway in between our vertical asymptotes, would be at the x-axis, since we don't have any vertical shifts. And then we draw Because it's negative tan, we go to the right and then down in amplitude, and then we go to the left a quarter of the period and then up in amplitude. And then we draw our S-curve through it, and then don't forget those arrows. So asymptote is always a little bit easier than domain. So asymptote, we always have x equals, and then we have to find the common difference. For cotangent and tangent, the common difference is always just the period, which is pi, and then we multiply the common difference by k. If our vertical asymptotes there's not a vertical asymptote that crosses the y-axis, then we need to actually add or subtract a number here. I like just saying the one that starts off the first cycle that we drew, which would be the one that I just circled, and that was at negative pi over 2. The shortcut here for tangent, we would always take pi over 2, multiply it by our b, which here was 1, and then add our phase shift, but we don't have anything, so it still stays pi over 2. So that's how we get that. Our domain is always the same thing as vertical asymptotes, but x cannot equal whatever we wrote. So pi times k minus pi over 2. And I'm sorry that it's kind of merging with, I'm going to actually erase that so we can see it. Okay. We would have pi k minus pi over 2. So if we wanted to actually double check our work, we could plug in numbers for k. They have to be whole numbers, positive or negative. So if I plug in 0 for k, I get the vertical asymptote that I circled. If I plugged in 1 for k, I get pi minus pi over 2. So I get pi over 2, that's the second asymptote if we're looking to the right. If I plug in 2 for k, I get 2 pi over 2, which is 2 pi minus pi over 2, which would be 4 pi over 2 minus pi over 2, which is 3 pi over 2, which is that third vertical asymptote that we drew. So everything's making sense. We have everything filled out, and we have 2 cycles drawn. So let's move on to number 8. Here we have 2 numbers now, so we're making this a little bit more complex. So let's actually start looking at this. Secant and cosecant, domain and range are both a little complicated, so we usually start at amplitude right away. Here we have a number for a, so that would be our amplitude, which is 3. And then we do have a number for b, which we said b is 1/2. So remember, if we are dividing by a number, that means our b is going to be a fraction. So for cosecant and secant, we always do 2 pi divided by b. So in this case, we would do 2 pi divided by 1/2, so we get 4 pi. Phase shift, we don't have any C, so that's NA or 0. For vertical shift, we don't have a D, so that's NA or 0. Alright, the other stuff in that table we'll go back and fill. Since we don't have a phase shift, we can just do our normal X and Y axis, which is through the middle of our graph. So now as we keep looking at this, we can still do that general rule is you put a tick mark halfway through the positive and negative y-axes and label that with your amplitude, and then a tick mark halfway through our vertical positive and negative x-axis and label that with our period. So we have 4 pi on the right and negative 4 pi on the left. So that means every tick mark here would represent 1 pi. And that's good because with cosine and secant, just like all of our other trig functions, we do end up always putting something at a quarter mark of our period. So let's actually start talking about that. So for secant, if we look back at our notes, secant is related to cosine. So that means our first u is actually going to be centered on our y-axis unless we have a phase shift, which here we don't. So this one's is always a little bit more complicated because if our u is centered on the y-axis, that means our first vertical asymptote isn't going to be the easiest to graph. So if we have this u, I'm just going to draw it real quick. If we have this u centered here, that means our vertical asymptote needs to go to a little bit to the left of the y-axis. that's always a quarter period to the left. So if our period is 4 pi, a quarter of that would be pi, which we already said was a tick mark. So our first vertical asymptote always goes a quarter to the left of our y-axis. And then, as we always do, I drew my first vertical asymptote, and then I go a period to the right, which is 4 pi. So 1, 2, 3, 4 pi to the right to draw my end of the period. And then since it's secant, we need to draw that middle vertical asymptote as well. So we have our vertical asymptotes here, and now we can start drawing our u's of the secant curve. So our first u is always upwards facing, and we already said that's centered on the y-axis, and we go an amplitude up. So I drew the dot, I can draw my u through the dot, and then draw my arrowheads, and then I go to the other vertical asymptotes, go to the halfway mark in between our vertical asymptotes, and then go down an amplitude. And I can draw a u in between it again. And then I'm done there. We need to draw a second cycle. So that means I'm going to go to the left since I have more space over there. I'm going to go a whole period to the left. So that's 1, 2, 3, 4 pi. So I'm going to draw my vertical asymptote at the end of the period on the left, and I have to draw that other one in the middle because we were dealing with secant. So right to the last u that we have is an upwards facing u, which means the next one to the left of it will be downwards facing. So that means I go to the middle mark in between our vertical asymptotes and then down however much our amplitude is. So here that's down 3 at -3. Draw u through it. And then again, the next set of asymptotes, we would have an upwards facing u. So that means I go up an amplitude and make a dot. If we had a vertical shift or phase shift, this would be slightly different. But here, everything's pretty easy because we don't have any shifts. So here we have 2 full cycles because we have upwards facing, downwards facing, upwards facing, and then downwards facing. So now we can go back in our range. If we look at our graph, all the way at the bottom, we're starting at -infinity. And then we're going up to -3. And then square bracket, because we do have a dot at -3. Union, and then we're starting to pick back up at the bottom of the upwards facing u, so +3, and we go to +infinity. So asymptotes are next, which we always say x equals. Again, we find the common difference, which for secant is half of the period. So our period is 4 pi, half of that would be 2 pi. We can also see that in our graph because our first vertical asymptote, which is right here, is 2 pi away from the next one. So that's our common difference, and we multiply that by k. And then we just choose any asymptote to figure out what we add or subtract in. I'm going to go back to the one that we started with, which I'm making look a bit thicker. That's at -pi, so I'm just going to subtract pi from this equation. So I get x equals 2 pi times k minus pi. I can plug in a positive or negative whole number, and I would get all the asymptotes that exist in this graph, because we do go on forever to the left and to the right for this pattern. Domain is the same thing, but we have x cannot equal, and we have 2 pi k minus pi. Alright, so that's it for number 8. We have our graph, we have our table filled out, and now we can move on to number 9. Number 9 is weird because we're actually going back to sine, which is not one of our other trig functions, but here we actually have a phase shift, so we'll go back and talk about that, and it's a good review for how to graph our original trig functions. Now, so if you remember, sine is the one that starts at the origin, so we can go in and start filling out this table. Our domain was the easy one here, which was always all real numbers, and we went back and filled out range afterwards. Our amplitude is still a, so 2. For period, we do 2 pi divided by b. Here, b is 1/3, so we actually get 6 pi here. So 6 pi for our period. Our phase shift, we do have a phase shift here. So for phase shift, we always do C divided by B, which here would be positive pi over 3 divided by 1/3. So pi, I'm going to try to write this as delicately as I can. Pi divided by 3 divided by 1 over 3, which these would cancel out, so I'm left with just equals pi. And then since it's positive, that means it's going to go to the left pi. Ugh. Vertical shift, we don't have a D, so we don't have a vertical shift. And then we'll go in, for sine, we have no asymptotes. So we can put an NA there as well. So we just need to go back and talk about range after we're done graphing. I kept saying, since we didn't have any shifts, we have a normal axis. We don't have any vertical shifts, so our x-axis still goes right down the middle. But since we shift our graph to the left, it might be helpful just to have more graph to the left. All right. So that's why I'm going to put our y-axis just a little bit off center. So now we have to figure out where our tick mark should go. If we made each red tick mark pi, I don't think we would really have enough space, so let's just make every red tick mark 2 pi. So we would have 2 pi, 4 pi, and then 6 pi. I'm just going to label the first one on the left because I don't feel like writing everything. So negative 2 pi, and then we are all smart enough to fill in that pattern. So we'll have negative 4 pi next, and so on. So when we graph this, we'll have to figure this out, which means every tick mark here, right? So every line that's drawn, whether it's blue or red, represents a pi on the x-axis. So now on the y-axis, we can still use our general rule since we don't have a vertical shift. We can go amplitude and then negative amplitude on the negative side of our y-axis. So a little bit different here because we do finally have a shift, and we can draw our sine curve. Sine curve starts at the origin. So I'm going to go in and graph what the parent function would look like first, and then we'll do our shift. So our parent function would start at the origin, and then it would end up back at the x-axis a whole period away. So it would end up back at the x-axis a whole period away. So that means we have to fit a whole wavelength inside these two dots, which means since we start at the middle, we'll cross at the halfway mark. So another way that we can think about this is if we start at the left dot, a quarter of the period sine, we go up first, and then a quarter of the period, quarter of the period would actually be right here, quarter of the period down, and then another quarter of the period, we would go down again, and then back up. So again, we said this was the parent function, so that would be our nice little sine curve, but we actually have to do a shift. So if we shift this pi to the left, we need to figure out how big is pi. Here we have negative 2 pi, so which pi to the left, we would actually start right here. So we can just shift everything one line over to the left. So here we would start, let me get rid of that other green dot. We don't need that right now. And then we would do 6 pi. So 1, 2, 3, 4, 5, 6. So that's where we would end up. So at the halfway mark, we'll be in the middle. And then halfway, in between the halfway mark, we would be at the top. And then likewise, we would be down here. So we need 2 full cycles. So here's 1. And then we can repeat that to the left. I count 1, 2, 3, 4, 5, 6. To the left. Alright. And then I know I'll be back in the middle halfway through. And then if I just follow the curve, if I go to the left, I'll go down first at the quarter mark, up to the middle, and then up to the very top, and then back down to the middle. So I can keep doing this curve and keep going up and down like a roller coaster, and my green curve is our function. Remember, we said the black one was the one without the phase shift. So we can go in and fill out the range. We start at -2, and then we go up to +2. And remember, our shortcut for doing this was D minus the absolute value of A, and then D plus the absolute value of A. If we wanted to remember a nice little equation for that. So we get 0 because we had NA for vertical shift, and then -2, and that's how we get -2 for our range. So that's the last problem on there. Nice little recall about sine and phase shifts. We'll continue this conversation in class on Monday, where you have to explain your graphs to somebody else who had a different version of this form. See you tomorrow.